Welcome back to the second video on Big Idea 2A. This is parallel lines cut by a transversal and the angles created therein. So we talked about the different angle relationships on the previous lesson. We went through corresponding angles, alternate exterior angles, alternate interior angles, same side exterior and same side interior angles, and why they're called that. If you want to look back here at the reference, you can see all of those relationships. Today we're going to talk about the if-then statements. We've been going through some if-then statements in class quite a bit, and specifically today we want to take a look and see if we have those angles, why is that special? Why does it matter? So that's the big goal today. So here, take a second to identify some pairs of same-side interior angles. Pause it. I'm going to give you them in just a second, so pause it so you can make sure you've got them yourself. All right, so 3, 2, 1. Let's get started. Angle Q and P, or Q and O, are a set of same-side interior angles, as well as angles P and R, same-side interior angles. Now, since those are sets of same-side interior angles, maybe there's an interesting relationship that comes from them. And that's definitely true. If you take a look at those two angles, they might look pretty interesting in that angle P is small, angle R is big. Okay? Those angles actually combine to form a special straight angle. They are supplementary. Now, they're not next to each other. Next to R is T, so that makes a linear pair. P and R are not next to each other, so they are not a linear pair. They're just supplementary. So we can actually write that down. And this is actually another postulate for us to go through. So we're going to write it down, but we're going to write it down up above on page 7. On page 7. It's the same side interior angles postulate. So we're going to draw a quick set of parallel lines. I'm going to do some vertical lines this time. And with those parallel lines, I'm going to put the arrows to show that they're parallel, as well as the transversal cutting through them. Okay? So if I take a look at angles 1 and angle 2, we'll call that 1, we'll call that 2. Angle 1 and 2 are supplementary. Angle 1 and angle 2 are supplementary. Okay, and for two angles to be supplementary, if you've forgotten what that means, supplementary means they add to 180 degrees. Specifically, their measures add to 180 degrees. This is a postulate. It's not something we're going to prove now. You might prove it in the future, but for our purposes, we're going to consider it to be a postulate, or a idea that we just assume is true. Like we talked about in class, it's kind of like a worldview. A postulate is really just a worldview. So our postulate simply says this. If we have parallel lines cut by a transversal, the same side interior angles will be supplementary. Okay, that is our statement. Same side interior angles will be supplementary. Now, as you look at those two angles, you may assume that they're supplementary, and they are. But again, we're not going to prove it. So let's use that to answer a few other proofs and to see if we can find out some other conclusions regarding other types of angle relationships. This next one here on page 9, example number 3 says prove the alternate interior angles theorem. We're given that we've got parallel lines. So that's a good start. We've got some parallel lines. Awesome. And in my class, we prove it first visually, and then we go ahead and we prove it on statements and reasons to make sure we can communicate what we're proving with our minds, okay? So we've got some parallel lines. We want to prove that angle 1 is congruent to angle 2. Those two angles need to be congruent. So in order to prove that, we're going to go through this. We're going to take a look at angles 1 and 3 first. Angle 1 and 3, oh, they're related. Oh, they're in between the parallel lines, so they're same side interior angles. And we just learned that same side interior angles add to 180. So I'm going to go over here and I'm going to put plus to 180 degrees. Okay? Now, if I take a look at angles 2 and 3, 2 and 3, they form a linear pair. They also add to 180. Plus, oh, it's the wrong kind of thing. Plus 2 to 180 degrees. Okay, so angles 1 and 3 add to 180 degrees. 2 and 3 add to 180 degrees. That's pretty good. They're one supplementary, the other one's a linear pair, which is also supplementary. So if I take a look at angles 1 and 3, and angles 2 and 3, they add up to the same thing, which means that they're equal to each other. So if I get rid of any related angle in them, I'll know that angle 1 and angle 2 are the same. So take a look at these two pairs. Is there anything that they share? Yeah, they share angle 3. So we're just going to eliminate angle 3, get rid of that, and now we know that angle 1 and angle 2 are the same. They're congruent. That's going to be our proof. We recognize that these add to 180 because they're same side interior, and these add to 180 because they're a linear pair. All right, so with that proof, we're going to go ahead and write it out. And writing proofs can be a little tedious, but there's some effective ways to kind of speed your way through it. First, our statement. M is parallel to N. How do we know that? Well, it's drawn for us here, and it's written here. So that's really just given to us. We're going to write out given. Okay, next. The measure of angle 1 plus the measure of angle 3 equals 180 degrees. Well, that's because they're on the same side and they're in between the parallel lines, or they're on the interior. So that would be same side interior. Okay, they're same side interior angles. All right, what about the measures of angles 2 and angle 3? They add up to be 180, and that's because they are supplementary since they're a linear pair. We're going to write that down, linear pair. Now notice how visually we talked about angle 1 and angle 3 adding up to 180, angle 2 and angle 3 adding up to 180. Now in class, I've talked a lot about how proofs are kind of like rungs on a ladder. You got to get from one to the next. And this is exactly what we're going to do here. We're going to look at these two steps. Step 2 here and step 3 here. And we're going to realize they both equal 180. Since they both equal 180, they're both going to equal each other. So let's go ahead and write that out. The measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. Both of those add together to be 180. And if you look over here, both equations equal 180 degrees. Now, switch over to algebra brain. We've got an equation to solve now. And you might notice that there's a certain value in here that's in both of them. Since it's an equation, I can subtract it out to make it disappear. The measure of angle 3, measure of angle 3. That's in both of them. So I can subtract the measure of angle 3 out, and I'll get angles 1 and 2. The measure of angle 1 is equal to the measure of angle 2. We subtracted out the measure of angle 3. Now that I've got this, I'm going to switch back over to geometry. This tells me that angle 1 and angle 2 are the same measure or the same size. They're the same shape because they're both angles, and they're also the same size. So what does that make them? That makes those two angles congruent. We're going to state that right here. This is actually called congruence, or the definition of congruence. So I'm going to write def of congruent. If you wanted to, you could just write the word congruent, or you could write down congruence, because we just showed that they are congruent. There's a lot of different ways to do it. But communicate, that's a big part of this lesson. Communicating your reasoning is the last big idea of this chapter. So make sure you're communicating your reasoning. All right, with that said, I want you to take a few minutes to try and prove the corresponding angles theorem. Okay, we've got the measures of angle M, and we got M and N, and they're parallel. Take a look at angles 1 and 2. You want to prove that those two are congruent. So go ahead and try to do that right now. I'm not going to write out the proof even in a second, but we are going to go over it visually. You should be able to write it out if you understand that visual step. Okay? So I'm going to give you a few seconds to do that. Pause the video if you need more time. All right, and 3, 2, 1. Just like with the last proof, we want to show that angle 1 and angle 2 are congruent. But this time they're in a corresponding position, not alternate interior angles. So I want to show that angle 1 and angle 2 are congruent. I'm going to look at angle 1 and compare it to angle 3. Hey, wait, those make a straight angle, or they're a linear pair. These two are same side interior angles. Since I've got both of those, I'm going to subtract out angle 3, and I find out that angle 1 and angle 2 are congruent. All right, with that said, we're all set with our second one. We're getting that then statement. If we have alternate interior angles, then they're congruent. If we have corresponding angles, then they're congruent. Hope this video has helped you. And in the last video in this lesson, we're going to go over all of the different congruences and other things that we get whenever we've got congruent, or not congruent, but parallel lines cut by a transverse.